part 2, we established that if we have a population of x1, x2, all the way up to x sub n, that the mean of that population will be the sum of the x's divided by the membership in the population. We've also established that if we took samples from the population of size n, small n, then it would generate the number of samples of n to the n power. And this can be looked at as a table of n columns and n minus 1 rows. And then we established that if we added up all of the entries in this table, that the sum of all entries in the table was equal to n to the n minus 1 power times x1 plus x2 plus all the way up to xn. Now let's see how that relates to the sample means. The first row is sample number 1. So the mean of that row is going to be the sum of row 1 divided by the number of entries in row 1, which is small n. The sum of row 2, the mean is going to be the sum of row 2 divided by the number of entries in row 2. And the mean of the final sample is going to be the sum of this row divided by the number of entries in that row. If we want to find the mean of the mean, then we have to sum this column and divide by the number of samples that we have. Well, the sum of this column is the sum of row 1 divided by n, the sum of row 2 divided by n, the sum of row 3 divided by n. So it's a sum of all rows divided by n. This is the sum of this column. Then, to find the mean value of all of the means, we have to take the sum of this column and divide by the number of entries in the column. The number of entries in the column is n to the capital N, n to the small n. Now notice, in part 2, we established the result that the sum of all rows, which is equal to the sum of entries in the table, is equal to our prior result, small n, capital N to the n minus 1 times the sum of all of the x's. So let's simply make that replacement. So what we have is small n, capital N to the n minus 1 times x1 plus x2 all the way up to xn. What we've done is replace the sum of all rows by what we established it to be equal to in part 2. That's divided by small n, and all of it is divided by the number of rows that there are, and this is going to establish the mean of the means. Notice what cancels. The n cancels to the n, and the n to the n minus 1 cancels with the n to the n, leaving a single n. So what we're left with is x1 plus x2 plus x3 all the way up to x sub n divided by 1n is equal to the mean of the sample means. But indeed, that was simply what was equal to the mean of the population, the sum of all the x's divided by capital N. So therefore, the sum of the sample means is established to be equal to the sum of the population, to the mean of the population. So the conclusive result, the mean of the population is equal to the mean of the sample means.